So in the improvement phase, this is where we really start driving continuous improvement efforts in an organization. One of the biggest things I think is important about current state and or the improvement phase is future state maps, right? You have your current state of your process and you want to create a future state and show how your change impacted the process. When I introduce people to future state maps, we briefly, have to kind of refresh our memory about what the types of process maps are, right? And earlier on in our lessons, we talked about what flowcharts were, what swim lanes were, what SIPOC diagrams were, what process flow diagrams were, and value stream maps. Now, our future state maps, for the most part in Lean Six Sigma, you're going to use value stream maps to do that bursting bomb or bursting Kaizen event. We'll talk about that here in a little bit. But you can use any of these diagrams to show a future state, as long as you're showing what the current state of the operation is, and then you evolve that and you use that future state to improve operation efficiency. That Kaizen burst, I call it a Kaizen bomb, and I made it as a little explosion. But what it does is it drives your current state and creates a need for improvement, and it gives your team a focus point for that map. Let me show you guys an example. Earlier on, we talked about Cool Dude Pizza, where we make pasta and pizza. We have our current state of our operation, and we want to take in consideration, of what our highest NVAT is. And then that becomes our focus point. Now, it doesn't have to be that particular area. Maybe you want to look at not overhauling a process, but, focusing on little things or little steps that you can improve. So maybe it doesn't have to be the highest NVAT or the highest wait time. When we look at this, you can use a Kaizen in any type of evolution. But we put a Kaizen burst there to give our team a focus point for continuous improvement. And it kind of helps streamline the information because, as you can see, that Kaizen really becomes relevant when you're placing the focus point on an area that needs the most improvement. Now, this is the same map here, right? I've just listed it a little bit different so you can kind of see the streamlined approach of it, right? Why did we put a bursting Kaizen bubble here? It's because this was our highest NVAT value, right? And so we give a focus point on this. Okay, so now what? Well, we're going to create a future state process. This is where we're going to set goals and base those goals on the analyses and set clear goals for what the future state should achieve, whether that's reducing lead time, increasing throughput, or improving quality. Now, the steps in here, we're going to set improvement goals, brainstorm and select solutions, and design the future state map. Now, when we set improvement goals, we're going to base that on the analysis, okay? And the goal here is to identify what your process should achieve, right? Whether that's reducing lead times, increasing throughput, or improving quality. You then can brainstorm and select solutions. This is where we're going to generate ideas for process improvement and select the most viable solution that aligns with the company's goals. And then we're going to design that future state map where we're going to create a visual representation of our process. Now, in designing your future state map, we're going to create a visual representation of the process. This visual representation should show a streamlined flow of materials, reduce the number of steps or handoffs in the process. Maybe you want to consolidate your efforts and blend two steps into one, right? And where you're putting things together and making them flow seamlessly. You're going to implement lean tools such as 5S, which we know is 6S now, Kanban, and Poka-yoke, right? We're going to improve that layout for better efficiency in our organization. And this is where we're going with this, right? Some key metrics that I want you to take in consideration is your process steps. How are you clearly defining those process steps to improve your process? Are the process steps relevant? How are we documenting the flow of materials? Creating that visual representation of how the process and information should move through the flow. Next, for our future state map, we're going to consider what's value adding and what's non-value adding, right? Distinctions between the two that, either it adds value to the customer or it doesn't. Now, some comparison that we can utilize is, between value and non-value. Our non-value added activities, excess inventory, does not directly add value. Overproduction, waiting times. You can look at it as, okay, but it might be necessary, but it's not value adding. When we think about that, necessary steps is our maintenance and setup times, right? Compliance and regulations, inspections, they're necessary, but they're not value adding. I mean, I guess you could look at it as value adding, especially the maintenance and setup. But our value, it directly adds to the product or service provision, the software development, the manufacturing aspects of it. When we talk about value, we talk about enhancing that customer's experience through customer service, maybe a better user interface design. And, overall, these are value-added activities. So once you get an idea of what's value and what's non-value, now what? This leads us to something called brainstorming, right? Brainstorming's a creative, group-solving idea generation technique. It's designed to stimulate free thinking and encourage the exploration of new concepts and solutions. It involves gathering a diverse group of individuals to generate a wide range of ideas on a specific topic or problem without judgment and criticism. I think that's key, is to not create that judgment or criticism, and we'll talk about that as we go. Basically, brainstorming is where you take the root cause analysis and you start forming ideas on how you can solve the problem. This is a great collaboration tool, right? Because once you get everybody on the same page and you get them in the same room or in the same meeting, that's where you'll start to see the power of collaboration. Brainstorming is where you're going to share your ideas, right? Some, brainstorming tips that I usually tell people as you go along is, list your issues. We're looking for quantity over quality. The more ideas we can generate, it's more solutions we can come up with as a collaborative team. We want to ensure that respect is given and we give everyone a chance to express themselves. And we're going from there, we're going to kind of rank our solutions or select it. Now, in that solution selecting, number one, ask, is it feasible? Think about your resources. What's your manpower, your equipment? Manpower is a really good example. Is it feasible? Is your project feasible with the team that you have? How do you judge effectiveness? Basically, where do you have the greatest impact on the process? The cost. If you're going to come up with a solution, you better damn well have a answer to how much it's going to cost to a stakeholder. I see a lot of times where people will come up with problems and they don't add any value, as they don't add any solutions. You're not there to discuss the problems I already know or we already know as a team. We're here to find solutions to those problems and work collaboratively to fix them. From here, you start to prioritize your list based off of this, right? And you select the most viable solutions. One thing I want to note as you're looking at this is that viable solutions should come from a cross-functional team, a team of Six Sigma professionals, maybe that have a baseline understanding of Six Sigma, but maybe more of an advanced um, aspect. And you can see this is why I say everyone in Six Sigma or everyone in an organization should have at least a foundational knowledge of, root cause analysis, doing different tools of Lean Six Sigma to optimize processes. Now, when we look at the improvement tools, right? I've already talked about process mapping. I've talked about Poka-yoke. I've talked about 5S or 6S as we know it. And I've talked about Kaizen events. Now, Kaizen events are really going to happen at that improvement phase, but you can use it during the analyze phase to understand your process. The thing that I want to talk about the most is how do you design your experiments? The design of experiments, or DOE, is a fundamental statistical approach that plays a critical role in optimizing and improving processes within various industries. By systematically planning and executing experiments, DOE enables organizations to efficiently explore the relationship between multiple input variables and their effects on the output. This methodology approach not only streamlines the experimentation process, but also provides a deep insight into factors that affect things such as performance. We can allow for precise adjustments and achieve those desired outcomes when we focus on designing our experiments the right way. DOE is a statistical method used to determine the relationships between factors affecting a process and the output of that process. DOE, design of experiments, is a powerful tool for optimizing processes, improving product quality, and reducing cost. The strengths of DOE lie in its ability to identify not just the main effects of individual factors, but also their relationship between the different factors, which is often critical in complex processes. Throughout its structured framework, DOE facilitates the discovery of optimal conditions that enhance process stability, improve quality, and reduce cost. Moreover, it supports the development of robust processes that are less sensitive to variation, therefore increasing customer reliability and customer satisfaction. When we talk about process reliability, we want to have consistency in no matter what we do in our process, because once we have consistency, then we can create a baseline measurement off of it and evolve from there. Now, there's different DOE risk factors that I want us to take in mind as we're kind of coming through here. We're going to identify what the levels are. Levels are the different settings or values that each factor is tested in the experiment. The choice of levels determine the range and resolution of the experiment, impacting its ability to detect significant events. How we respond to those changes is also a risk. The response is the output or outcome measurement in the experiment to assess the effects of the factors. Some characteristics of response times your response should be quantifiable, relevant to the objectives, and sensitive to the changes in the factors, being aware of those factors. Last thing is experimental design. Experimental design refers to the structured plan for conducting a design of experiments, specifying which factors to vary at what levels and at what level of contributions or combinations we can have as an organization and team. The DOE mapping process is relatively easy, and I like kind of showing a mind map here. When we first start with this, we have to look at what our outcomes are. What are our measured responses? What are our predicted responses? Those hypotheses in our situations. Some factors that we consider is, independent variables and dependent variables. Early on in lecture, we talked about a regression analysis, and you can figure out what is the dependencies of the variables. Well, we talked about a single regression, and we have a multiple regression. Now, here's the thing. You can take those and bring that in to your DOE because you've already done that during the data collection phase. We understand what the interactions between what maybe factor B and factor C are versus factor B and factor A, right? When we look at our production level, do we have a high variation or do we have a low variation in our process? Overall, when we map our process or we map our design of experiments, we start here. Now, some of the things that we can do is apply this in different realms. Number one, we can apply it in process improvement. This is where we enhance the efficiency and effectiveness of a process by identifying and controlling key factors that influence its performance. In Lean Six Sigma, we also want to look at what our production design is. Do we want to develop new products or improve existing ones? Sometimes the best approach is to completely change, right? And I know that might be looked at as wrong, but sometimes with the advancement in technology, some of your systems are outdated. Some of your processes could be, structured through AI means instead of relying on human error. Overall, we look at quality and the metrics that quality can establish, right? When we ensure that products and processes consistently meet that voice of the customer or those predefined standards, we can identify what are critical quality factors. Now, we can use root cause analysis to do a DOE and use that data that we collected from it. And in it, we can evaluate maybe what the capability of a process is, how it relates to specification limits, and we can use this to effectively analyze what are key process parameters. A little bit of an example here with a DOE matrix, kind of an easy way of looking at this is seeing the factors and how they affect each other. DOE benefits, number one, when you design your experiment, you're going to create a streamlined approach and better efficiency in your organization. How you design your experiment can give you valuable insight to your processes. And you can use it to connect the dots on improving organizational processes. How do we optimize our process? That's also going to be a metric in DOE. And creating that robustness or durability in our process is going to be king to process change. Planning and designing of experiments is a critical step in the process improvement and problem-solving methodology. When we use effective DOE, we can plan in ensuring that the experiments are structured correctly to yield relatability and insightful data. We can define what those clear goals are in that project charter, right? And we can reuse that during our experiment. Understanding what you're trying to aim at is key, whether it's improving a process, solving a problem, or optimizing a product. You want to identify maybe what some responses are, determine how the factors or the effects could happen. So in the DOE planning phase, we can use this basic format of, we'll go through our planning phase and, These are like timeline dates that you can utilize. And this is just an example of a basic framework for DOE. But how are we going to select those factors? What's going to be the determinant levels? How are we going to choose our process design? During the execution phase of DOE, that's where we're going to conduct the experiment and we're going to collect the data. Now, this happens during that improvement phase, and you can blend it with your Kaizen events because you're going to be conducting data analysis on the processes that you kind of streamline and make efficient. So when we look at this, we can use that execution phase to kind of drive our efforts. From then, we're going to look back at our process and analyze it. Maybe we're going to look at data or, how do we build effective models? In the conclusion phase, this is where we're drawing conclusions or, assumptions about the data, making it educated and saying, okay, well, we know that this variable is going to impact that variable, leading to an outcome of this. And then we implement what the findings are. This helps us identify what resource allocations we can use, personnel, equipment, materials, and allows us to make educated decisions. And after collecting the data, we can use statistical analysis tools to interpret the results. Overall, this is going to give us better insight on our processes when we conduct these experiments. DOE steps, you're going to define the problem, you're going to design the experiment, you're going to conduct the experiment, and then you're going to analyze the data. And I guess we could put a fifth one on there where we say continuously evolve. But this becomes a baseline metric for how to conduct a DOE. What is going to be your experiment? Overall, design of experiments allows us as Lean Six Sigma professionals to look at our process, and it gives us a framework to do continuous improvement efforts. When we design the experiments, we can identify variables that maybe have interdependencies or relationships, right? We can understand what constraints are in the process, and we can improve it through continuous improvement.